Alright, so this is going to be a quick video on box and whisker plots, 5 number summaries, their relationship to the distributions, as well as a little touch on the relationship between the mean and the median through both the histograms and whisker plots. I have another video that I made quite some time ago on how to actually make box and whisker plots and histograms on the calculator. This is not that video. That is a different video. This video will just cover the relationship themselves. So first up, let's remind ourselves what the 5 number summaries were. So if you recall, 5 number summary was the minimum, the first quartile, the third quartile, and the maximum. These 5 numbers are what's used to make up the 5 number summary. This 5 number summary is what dictates what our box and whisker plot will look like. So the way I construct it personally, instead of a dot, I draw a line at each of these locations above a number line. And then and then I will draw a box that connects Q1 and Q3, and I will draw whiskers that connect minimum to Q1 and Q3 to the maximum, typically. Now, and also, it's important that you draw a line through the box to signify where the median is. Box and whisker plots don't really show mean, they show median. I'll explain how to sort of picture where the mean would be here in a moment. Now, you'll notice this maximum here is displayed as a dot rather than part of this line. There is a reason for that. The reason is because this point happens to be an outlier. 14 in our data set was an outlier according to data that we had. Now, if you remember, we mentioned something called IQR in the summary statistics. The IQR is found by Q3 minus Q1. It's your interquartile range. It's the same thing as your range, but instead of your range from max to minimum, it's your range from Q3 to Q1. So it's in between the quartiles, or interquartile range. It's basically space that this box takes up on the number line, right? So remember, when you're trying to determine whether or not something is an outlier, what you would do is you take your interquartile range, multiply it times 1.5, and anything that is further away from Q3 or Q1 than whatever that value is, that point would be an outlier. So in this case, our interquartile range is 4, because 7 minus 3 is 4. 4 times 1.5 is 6. So we would take our Q3, 7. We would add 6 to it to get to 13. And anything that is bigger than 13 would be an outlier, like 14, which happens to also be our maximum here. So anytime you see a dot like this in one of these box plots, please keep in mind that is an outlier, and that is the calculation that is determined, that is used to determine whether or not it is an outlier or not. So we talked about how we describe histograms, box and whisker plots, dot plots, distributions in general. One of the things that we're asked to describe is their shape, right? So this is one of the descriptors that we'll use for some of the shapes, right? So if something starts off very small and gets bigger as we go on, and then peaks and then tapers off really fast, we say that is skewed to the left. You can almost imagine someone taking a, nice symmetrical data and sort of yanking on the left side of it and pulling it off to the left. So this is what we will describe as skewed left. Likewise, something that is skewed right is where the tail goes off to the right-hand side, and then something that is symmetric doesn't have a skew either way. It can be, this shape, it can be any other shape that's symmetric. This is the most common, but it'll look like something like this. All right, so this is the histogram for data that would be skewed to the left. So we've seen, again, in this distribution, the tail goes off to the left-hand side, or it tails off to the left-hand side. We can imagine that the mean would be somewhere around here. We like to describe the mean as, when you're looking at a data set, it's a spot where if this was a solid object and you were trying to balance it on your finger, you could balance it right where the mean would be. It would be the balancing point for the data. So you can envision maybe you're trying to balance this on a scale. Um, it wouldn't be right in the middle because some of this stuff goes off to the far hand side, but it would be a good balancing point. Now, just to confirm, I've done the mean and the median calculations for this already. We see the mean is about 8.7 and the median for this data set is at 10. So half of the data is to the left of 10 and the other half of the data is to the right of 10. But we know the mean would be right about here at 8.7. Now, when we convert this to a box plot, we see that in this case we happen to have 3 outliers. These 3 points all are excuse me, less than 1.5 times our IQR for this, but we see that the box is scrunched over to the right hand side and is stretched out as we go to the left hand side. So when it is skewed left as a histogram, it will also appear skewed left as a box plot. Now for data that is skewed right, similarly we have a median which is at 4, but we have a mean that is at 5.1. We see that our balancing point then would be right here at about 5.1, whereas our median is here at 4. When we convert this to a box and whisker plot, we confirm that our median is at 4. The halfway point would be a little bit, or I'm sorry, the balancing point would be right at about 5.1. And again, we see that the right-hand side is stretched out a little bit, signifying that it is skewed to the right. So just to recap real quick, any data set or any distribution that is skewed left, the mean is to the left of the median. Any distribution that is skewed to the right, the mean is to the right of the median. The mean will be pulled towards the direction of in regards to the median, and in regards to its relationship to the median. Now, for something like this that is symmetric, we can assume that the mean and median will be right on top of each other, or at least very close whenever it's approximately this shape. And again, when we convert this to a box plot, we see that, again, it is symmetric in the box and whisker plot, just like it was before. Most of the data in this case happens to be around the middle. It's stretched out a bit in either direction, signifying it's symmetrically skewed, if you will, quote unquote. But since it is symmetric, of course, we don't describe it as skewed. There is another name for data that fits this pattern. We refer to this data that fits this shape as approximately normal. We'll get into a longer discussion later about what that means. There are a few more cases that you might encounter. There's the case of data that is uniformly distributed. This doesn't happen very much when you're collecting data. This is more something that would happen in a probabilistic setting. But you might have something that is approximately uniform, right? So for example, if you have in this case, a 10-sided die, you would expect that you would roll about the same amount of each number each time, right? Of course, in reality, it wouldn't be this perfect, but a uniform distribution is when each of the quantities occurs exactly the same amount of times. So something that is approximately uniform would be something where it would be a distribution in which amount of times something occurs is approximately the same across the board. And then anytime you have two different values that occur the most, you have something that would be polymodal, if you will. So something that is bimodal has two peaks or two modes. Something that is trimodal has 3 peaks, and so on. All 3 of these you could refer to them as unimodal, whereas this one would be bimodal. This one you wouldn't call it uniform. But you can describe this as bimodal, trimodal if it has 3 peaks, etc. When you're looking at the box and whisker plots for these, for the uniform one, you can kind of tell if it's uniform or not just by looking at the box and whisker plot. Only because you'll see that each of these sections is equal size, right? This goes from 1 to 3, this goes from 3 to 5.5, 5.5 to 8, 8 to 10. So there's the same amount of data in each of these boxes, if you will. When you are When you're looking at the histogram for something that is bimodal, however, it is not immediately obvious that there is anything significant just from the box and whisker plot. Just looking at this, it is a bit unusual because you see that there's a long tail off to this side, suggesting that there's a long whisker on this side, suggesting it might be skewed to the left. However, the box looks like it might be skewed to the right, so there's competition on which direction the skew is. This is because in my histogram I did not balance it perfectly. Um, so it's not immediately obvious if there is skew and where it would be. So you cannot tell things like how many peaks or how many modes a distribution has just by looking at the box plot. You'd have to look at the actual histogram for that. You can see that the mean is, in this case, to the right of the median. That is not something that will happen all the time. That just happened to happen this time. And yes, that is everything you need to know about box and whisker plots.